everyone. Welcome to another stream, episode number 7 with me, myself, Phase 101 or Prince Phase 101, and of course, our special guest, Ozzy. Welcome, Ozzy. I need to unmute Ozzy actually.
Okay, check, sound check.
Yes.
Can you hear
Hello,
me?
Ozzy. Hello. You're fine.
Yeah. So good evening, everyone,
Yeah.
and thanks for having me once again.
So, as always, we go to the usual ritual. Okay. Is it okay? Yeah. So, basically, guys, you know what I'm going to say, basically. Please like and subscribe to our YouTube channel, the Phase 101 YouTube channel. Remember that under each video, there is more to them, and there are sources related to each episode. You will find the sources on Mega. Okay. Please like and subscribe to our page. Like our page, not subscribe. Like it and follow it. And then subscribe to the Phase 101 Facebook group and the Commodore Dev Facebook group. For those that want to have a chat with me or want to ask something, please come to Discord. You can send me messages on Facebook, but I am not so often there. Let's put it this way. For those that do not like neither neither Facebook, neither Discord, you can come on Telegram. I have also a Telegram group. All the links are in the upper right hand corner on top of Ozzy, basically. So there's no issues there. For those that want to support us, you can either subscribe in Patreon or in Coffee. Both of them are the same, and you will unlock currently 73 videos. One last thing, just to remind everyone, the Retro Programmers Inside and Phase 101, we launched the next game jam, which is racing cars. Please see the rules. There is one particular rule that was added so that it's obvious that it was made for the game jam of RPI and Phase 101. So from that we pass to this. Why we are here today. Okay, what's going to happen today? So basically, I know it's my screen. You tell me what's there. Well, it's intentional. So basically, as you know, Ozzy came second in a demo competition that he participated in using his AProcessing framework, and this is the demo. Let's watch it. And So today, okay, we are going to talk about the demo that Ozzy did, and he is going to explain things in more detail in relation to the demo, what there is in it actually. He already spoke a bit in the last episode, but it was a brief, brief one. Now today we decided that it will be an in-depth discussion about it. So that's why we are what we are going to do today, basically. So I pass my the speech to Ozzy now, and we can start.
Okay. First of all, I'd like to apologize for my voice because I got sick in the weekend, so I'm not fully recovered. My voice is not 100%, and sometimes I still cough. So apologies in advance for this.
That
But
is dedication, guys. Dedication.
yeah, dedication. And while I was sick, I also have some ideas about the car competition, the car challenge,
You
I
see?
would say. Yeah, some new idea because when you are stuck in the bed,
Yeah.
you have time to think about something, and I started thinking about cars this time. So this is dedication, yes, of course. So yeah, just let me repeat something for the people that didn't follow the last episode. This is just a little simple, not complicated at all intro. It was presented at Flash Party 2022. It came second, and very proud of this position, I will say, this award. And it was meant to be a 16 kilobyte intro, but I failed, and it ended up being a 19 kilobyte, even if there's no category for these sites, but my target was 16 kilobytes. But the most important thing for me, it was that it uh, should be possible to run the intro in an OCS machine. And in particular, I was targeting an Amiga 1000, which is the very first Amiga. And initially, I thought it was good to stay under the just run on a stock Amiga 1000 with 256 kilobyte of chip RAM. But I didn't consider that the operating system with such a small space is taking too much, and so you will need at least the expansion to 512 kilobytes for chip RAM to run this. Other than that, I also tried to run this Demona 1200 on my 600 and emulated on Mister and various platforms. It seems it works just fine on all platforms. Of course, I didn't test on some exoteric like the P-Storm or whatever. I think Carlo did. It should work also on a P-Storm or Pi-Storm, but very happy that runs on lot of quite a lot of different Amiga setups, classic Amiga, of course, and of course on FS which is my favorite emulator. So the intro is available to everyone. You can download the executable or the ADF file from Poet or GitHub. And as I always do with my work, I always publish the sources on GitHub. So if you want to take a look, I'm happy, I will say. If you want to copy, to redistribute, if you want to make your own triangle version, I am very glad. I won't ask for anything, of course. Maybe just mention that I'm the original author, and that's it. So the compilation instructions are quite easy. If you just need WASM, if you like cross-compiling, WASM is perfect because it's a multi-platform assembler. You can run on Linux or Windows or whatever, even on Amiga OS 3.1, I think. And I remember I ran WASM on 2.05, so it works just fine. But if you prefer doing the old way like I do, you can also use devpack on a real Amiga, and there is let's say a batch file inside that just run the genam, which is the devpack assembler, and it will build automatically the final executable for you. And of course, if you still are in trouble with the compilation, if you want to compile and get the executable and modify, just ping me. I will be happy to answer the questions if you have, of course. So having said that, I would say we can start. It would be just a different stream. It's meant to be just like a chat with good old friends instead of a real, let's say, assembler lesson. But that's it. This is a little bit different. You can, if you want to go to the slides and go to page number 2, we can just discuss how is the initial setup, what I had in mind, and why I did certain things, why I didn't do other things. So this is the screenshot that was copied from the GitHub page, because I didn't have time to rip other screenshot, but for me this was quite good because it shows some feature in the demo. And the first thing that you can notice that we are on a far low-res screen, like most of the Amiga demos. I think it's the most common resolution. And what's different here, let's say we have an upper part, so the high part of the screen, it's 320 pixel width and 224 pixel height. And the remaining space is taken for the banner, as I call it, so the tile banner. And one of the things that you can do with your Amiga, and which is very cool and quite uncommon on other systems, is that you can instruct the copper list to change the settings of the screen while you are painting. So this is a good example of that, because the upper screen is a dual playfield mode, is 3+2. It means that we have a foreground with 2-bit planes, and that I use to draw the triangles, and just that. And the background is another playfield, and it's meant to be used for the background assets. And in this case, for example, the pyramid and the sand. And when the beam reaches position 224, I switch and I say, okay, we are done with the double playfield. We go to the single playfield mode, and I don't remember, I think it's a 2-bit plane mode. And so we have this change of screen mode in the lower part of the screen. Oh yeah, it's two playfields, single buffer. The double playfield part regarding the two playfield that are used to draw the triangles is double buffered, and this is something that you will, as a coder, you could need, because the drawing triangles and making all the calculation takes time, and you don't want to draw in the bit plane while the ray is processing, the DNIS is processing this very same line. So you get this strange flickering effect that you don't want. So another benefit of the Amiga is that you can just change in the bit plane pointers. You can swap from the back and front memory where the triangles are drawn, and that's it. You get rid of the flickering as long as you stay in the time limit of the frame, of course.
Can I ask you one question? The platform, you're having the platforms are yellowish to orange or something like that. Are they on a separate? So my question is, are you using copper there, or are you using just bitmap to display the platform?
The way it's done, it's very simple. At start, before the game loop begins, I draw all the assets on the screen. And what I do here, I just draw rectangles on one color, which is color number 7. So the 3-bit planes are set to bit 1. And so you get color 7. And inside the copper list, there is some portion of the copper list which says, okay, if the beam reached the position X, Y, of course, change color. And this is what I did. What I did. So it's a mixed. It's, let's say, the CPU is splitting a rectangle of one color, and this color is changed dynamically into the copper list.
Okay. So I asked you that because you could have used colors also. So I just wanted to see if you're using more than one bit plane or you're using the copper. But yeah, okay.
I will anticipate something. Since I want to stay into a reasonable size, executable size, if you load assets are very expensive in terms of kilobytes. When you program an intro and you have size constraints, you should, in my opinion, you should do things programmatically whenever you can. So in this time, a platform is a rectangle, and you can, of course, draw a rectangle with your deluxe paint or whatever. But if you are able to synthesize the rectangle with a few lines of code, you will save much space.
Yeah.
And this is why I took this approach, and why I used the color color 7. It's because I have this, let's say, pattern of 1, and when the compressor is going to compress this portion, it just says, okay, it's just FF, it's just a bunch of FF bytes, and it's easier to compress and to not exceed some threshold size. So this is why I picked this way. If you listen to Dario Bellicus, he had some really crazy ideas how to even save more space and shrink the final executable further.
I was going to tell you, the pyramid, the pyramid,
yes,
the top part is the one is the same as what you have further distance. Is that a copy and paste from the original? Are you doing that during the code, or you just created the image like that?
This is explained, I think, on
Okay, then nothing.
on the okay. If you want to discuss this, we can go
No,
directly to
if you're
slide
going to
number
explain it
4.
later on, there's no need to answer it now.
Okay, we can go to slide number 3 and then to number 4. So you will get your answer.
Yeah, don't worry. But let's continue with this one then, and then when it arrives, you'll answer me. Don't worry.
Okay, so go to page number 3, please.
This one?
This
is 3.
one, yes, where there are my hand-drawn numbers because
Yes.
I use the tablet
Yes.
to do this stuff. But here it's just the composition of the scene, and I just wanted to mention that I used hardware sprites, and the sprite number 1 is the sand. And the sand, if you notice, it takes 32 pixels of wide. So this is why I had to waste two hardware sprites side by side. So sprite number 1 and sprite number 2 are just used to plot the pixel of the sand, the grains of the sands into the foreground. Then we have the spaceship is sprite number 3, and this is what Rengen calls attached sprite. You can overlap two different sprites, and you get 4-bit planes in total. If you don't know this, just read the Ramjan book. And so you can use the last 16 colors from the palette, and you can draw something that is not just recolored. So this spaceship is a sprite, is an attached sprite. And the same thing is for the sprite number 4, which is the dynamite. On bomb jack, there is a bomb here, a bomb. I changed it to my artist decided to change to dynamite because it was cooler, probably. I don't know. But yes, this is another attached sprite. In this screenshot, you don't see, but there is also another spaceship which carries a bomb and drops the bomb in the middle platform and then goes away. And this is also a sprite. And there is some strange trickery to make appear that the dynamite is dropped to the platform. I won't go into that. I had to make some changes. But yes, this is essentially the only hardware sprite that I use here are this one, and I think I used all the available slot because 2 for the sand, the twister sand,
You're using
and
5.
other 2 for the spaceship, other 2 for the dynamite, and other 2 for the other spaceship. Maybe something's left, but whatever. I just want to mention that all this stuff that is moving on the screen, which is not triangles, are hardware sprites. And notice that you have a big spaceship on the top right corner of the screen. And this is not a sprite. This is the very same image, but is pasted in the bit planes. And it's scaled. Inside AProcessing, there is a function which, if you give an image, it will double the size vertically or horizontally. Why I did that? Again, to save space, because I reused the image of the very small spaceship and scaled programmatically, and I didn't have to copy another asset inside buried into my executable. So this is just my choice, of course. But if you look closely, it's exactly the double of width and double of height.
Yeah.
Okay, so let's go to slide number 4 so we can answer to your question.
Yes. There you go.
And this is what the artist sent me. And as you can see, on the left side, there is the original bump jack assets. On the right, it's stuff from my artist. He tried to make his own version of the assets. So it's quite similar, but it's not the same. So we didn't rip off anything. It just redid from scratch everything. And as you can see, the top part of the pyramid is just one big asset. And of course, it's a space waster, but I can't, sorry, I can't define all this programmatically. I tried to look for some patterns inside, but at the end I saw that my algorithm to describe this picture with just code was getting too much fatter and fatter, and I decided to just include the original asset from the artist. But and the same top pyramid is recycled to and copied to draw the pyramid on the right side, which is far away, as you notice correctly.
Yeah.
But at first glance, this is not so obvious. A lot of people who were fooled about this. They thought there were two different pyramids, but this is exactly what you said. So the top pyramid, the top left pyramid is equal to the right. So it's just a little trick that I used, and I think it worked.
Yes. Actually,
And I saved a lot of space because this is a pretty big picture,
yes,
and
it is.
it's 3-bit planes. So it's a lot of space saved for me.
Yeah.
It's just a bleeding routine which has copies and bleed on another position. That's it.
I also noticed how he improved the graphics from the old to the new. The detail is a lot better than the old. So yeah, I think even if you look at the bottom, you know, the triangle, the square, and the triangle, you can see that the detail is a lot better. Then so I think it did a good job there also in terms of how he improved the graphics, you know, the graphics, the pyramid shape basically.
I agree. Eric made a very good work. I definitely am very happy with the final result.
I have another question
still,
to this.
I had in mind I don't want to include the assets. I want to write an algorithm in assembler to reproduce these assets.
Sure.
But it was very hard, very, very hard.
So the other question is, you have 8 colors on because you are using dual playfield, but I see that there's one color missing there. So you have black, blue, then the colors of the pyramid, but there is another color. There should be another color there, which is blue, I think also.
The black is missing.
Ah, okay.
The black is missing, and I will just tell you later
okay.
what's the story behind the black.
Okay.
Because I had an issue with the black. But of course, if the artist wanted to use the black, he could use it, no problem at all, but it must be black.
Yeah.
So this is a constraint.
Yeah. Anyway.
And if you notice, there are the three tiles.
Yes.
These are 16 by 16 tiles. And again, I picked this solution like the original Bomberman creator
Oh,
did
hello,
back in the
Amikin
days,
TV.
just to
Hello.
save space.
Hello. Thanks for passing by. Sorry, Ozzy, for interrupting you. Yeah. Thank you. We are talking about Amiga demos, and because Ozzy came second in a game in a demo competition, and he's explaining it. So yeah. So shall we pass to this next slide, or you need to talk more, Ozzy, on this one?
Okay, so yes, you can go on and go to page number 5.
Mm-hmm. Okay.
And this is something that I already explained. The big spaceship and caused a lot of headache because I wanted something on top of the sandstorm just to make sense of the sandstorm.
Yeah.
And but I didn't have available bytes because I was already over the threshold of bytes. Didn't want to include any other graphic stuff. So what I did is I picked the small image of the spaceship and I doubled. And if you go to this GitHub link,
Yeah.
and this is the routine that I wrote, which does just this,
So
just copy and paste in the browser.
this one.
Well, just use the URL that
Yeah.
I gave you inside the.
There you go. That's the routine. Let's make it a bit bigger. I think that's better. That's the routine to scale in X and Y, or in X only? In X and Y?
X and Y. This,
Yeah.
if you read the comment at the top, this function doubles the byte on the lower part
Mm-hmm.
of D0. For example, if D0 least significant bit is 1011, the function stores the lower word. So what you have to do is just to cycle for each byte, and he just doubles it. So as you can see, the routine it's quite small,
Mm-hmm.
and the final size is not comparable to the final size of an image, 64 by 64 image with 3-bit planes.
Yeah.
I think I saved some bytes. Okay, it's not much if compared to, let's say, what the full capabilities of an Amiga, but still, when you do size coding, you really try to scratch
Yes, of course.
the bytes, even when it's not really necessary. So this is just I use this routine for scaling graphics. Maybe there are some other applications. I don't know. For right now, I just use for scaling. And of course, if someone here notice something or has a better idea, I can do this routine with less instruction and which will let me save another byte of code. Please do a pull request. And if all my tests are passed, I will include in the AProcessing GitHub repository, of course. And so this is
Well,
my.
I have one small suggestion. You are saving registers D1 and D7, right? Am I right?
Yes. Yes.
So you do not need the zero. You're not saving it, right?
Yeah, because
Yeah.
let's say for each routine in the documentation, I state, okay, these registers are trashed and these registers are not trashed.
Okay. So the only registers that you're saving is the ones that you do not want to trash, which is D1 and D7.
Yeah, the
Okay.
zero is not, I overwrite the zero because the zero is where I put the final result.
Uh-huh.
So after that you jump into this routine, you must read the zero, which holds the final result.
Okay. My
So
question to this is why from D1 you want to use D7, not D2? Do you have a system where certain variables, certain registers, you use them for something and other registers use them for something else?
I usually start from D0 and go to D1. So D0 is usually what I use
Yeah.
for returning the value unless we have some valid reason to use another data register. And then I just use D1, D2, so I
Yeah,
go
but in this
progressive.
case you're using
But
the
for,
7. In this case you're using the
yeah,
7. So I wondering if there's a reason why you use the 7 and not the 2.
because for it's just my convention. I use D7 when I iterate with the debug.
Ah, okay. That's okay, that makes sense. So that's why I ask you, are you using D7 for something? So
Yeah,
iterations, you always use D7.
let's say that my general rule, and this is my made up rule,
Sure,
it's
sure, sure.
not
Yeah, 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 yeah.
just
Understand.
invented by me, is use the last data register for counters
Mm-hmm.
or something which is not related to business logic, I would say.
Mm-hmm.
And for the result of computation and the results of whatever you have to do, use D0, D1, until you have registers available, which are a lot because we have from D0 to D7, so 8 data registers are a lot of registers, so
Yeah,
I'm
yeah,
pretty
yeah.
happy with this. If you use the vampire, you get, I remember, 32 data registers. If I remember correctly. I don't know.
Well,
So
that's a
this
different
is,
story.
yes, some exoteric, I would say, because it's not what Motorola had in mind back in the days, but this will prevent you to save to the stack each time. You
Yeah,
can you can get rid of moving to the stack, popping and pushing because it takes time. So every time you use move M and you push into the stack, it's a lot of cycles.
yes.
And of course, if you had a lot of data register, makes sense to try to avoid. But so this is not the topic for today.
Yeah, 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 yeah. I'm just do you use MoveM in all of your routines, or you just is this one happen to that you use it?
It depends of the routine. The general rule is preserve if you can what you are trashing, but for very time crucial sensitive routine, I don't care about trashing or not. I don't I if I can I just avoid pushing and popping to the stack. But this is what I call a pre-calculation routine because this stuff is usually made outside the game loop. When you init the program, you calculate the assets, and this is not time crucial for me. So it makes sense to add movem.l.
Okay. That makes sense. Okay, yeah. So shall I pass to the next slide?
Yeah, yeah, you can move. I
Okay,
think we are
6.
to 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 slide 6.
Yes, it's there.
Okay, and in this slide, I will talk about the sky.
Hold on. Sorry, I told you it's there, but I didn't switch the screen. Sorry, it's there.
Okay, okay, it's there, but it's not for everyone.
Yeah.
Perfect.
So,
So if you notice during when the demo runs, the sky changes color. And what I did, of course, is the good old trick with the copper list. So I wait a certain line position, then change color. Wait another line position, change color again and again and again and again. And I have a lot of, let's say, shades of colors in the sky, which is good to my eyes. But what I wanted to do, it what we call interpolation. I wanted to go from one color to another dynamically. And so, and as I told you last time, when you do interpolation, you have to use this infamous divs extraction, which is quite expensive in terms of CPU cycling. So what I did, I created, when the program starts, it creates some tables. So for each shade, it creates a table from color X to color Y. And this is what I'm doing here. If you open the sky shades.s, you can see the relevant part of the code. And this is just a custom version of the map routine that we saw last time. And this is what I did. I don't know if there are better ways to do this, but it's quite compact. I set into D0 the start color and into D1 the destination color. And I say in D7 there is this counter, and I state that I want these different colors, number of colors that I want to have to reach the other color, and then I just use the routine. And then here I apply the routine. And it's quite long. It could be optimized probably, but I saw that the shrinkler, which is the compressor I use, was compressing a lot of this. He found a lot of patterns, so I didn't use Debra or iteration. But
you're
the main
using
thing
JSR
here
here,
is
though.
the build color table, yes.
Why is that?
And if you go to the slide, there is a link to the build color table.
Mm-hmm.
And because the build color table routine is not part of the bomb triangle intro, but it's inside AProcessing.
So
So
it's a different section.
yeah, it's a different repository. What I
Yes.
use here is a feature of Git, and I don't know if you know this feature. It's called Git submodels. You can link to different repositories in Git, and you can just state for this particular repository, there is a dependency, which is this other repository at this particular commit. And what I did here is I just said, every time you want to build the demo, you just take this commit from the AProcessing repository, and there you will find the build color routine. And the link of the routine is in the slide.
Yeah, which I showed, no?
Oh, yes, this is what?
This is the pre-calc call tables, and this one is the shades.
Yes, this is the build color table. If you go to the top, there is the usage. You put into the, there should be a comment. So it's in the other, inside AProcessing.
Yeah.
There is the comment, and this says that you should use D0 as a word, and you put the color code. Where do you want to start? And then the color code, where do you want to end, and then the number of steps, and it will build the table. Probably there is something also in the RemGem book that should do something similar or exactly the same. I don't remember. But this is completely by me, and it's quite long. I think we have space here for optimization, I think, because it's more than 100 lines.
Yeah. Now I recognize it. Yes. Yeah.
Yeah. Again, if you can get the same results with less instructions, please send me a pull request.
No.
And I'm very sure here there is space for optimizations. I'm so sure, because it's too much instructions. I think we can save some lines, of course. Okay, and returning to the slides, I just wanted to mention that the same technique for the sky was applied also for the sand, but this time the sand never changes color. It's just a fixed value inside the copper list, so it's nothing fancy at all. And the sand, the sand which is on the bottom part of the stop screen is just a tile again. It's a 16 by 16 tile, which is repeated. And honestly, this is the asset that for me it's not great, because the viewer here just realizes almost instantaneously that this is just a tile repeated on the x-axis. So, but again, I prefer a bad or not so good tile, but it is made by me instead of copying from the others. So for me, it's good, and I'd like once again to thank Eric for his great work. Okay, so we can go to slide number 7, I think. Okay, this is the result of a talk I had with Dario, and I want to really thank him, because he's always very available to answer all my questions, even the stupid ones. So I had a problem here. The problem is that the left pyramid is going out of the screen. So in the first versions of the demo, you see that the sky appears on the left of the pyramid. And this is because there is a region at the very top, at the very left and the very right of the screen, which is not fetched by Denise, because Denise fetches bit planes data and just copy the data to the screen into the bit planes. But the bit planes doesn't start at the very left edge of the screen. Of course, in your emulator, you can set this option that if you want to overlap the bit planes with the border, no problem. But since I use my CRT monitor, I had this unpleasant picture, which is, it seems that the pyramid was cut at the left. So how to solve this? My first assumption was, okay, I just write into the copper list that when the beam reaches a particular X position, I change the color. And then when at this very same line, when the beam reaches the right edge, I change again to the background color. And so again, so for each line, it means I had to add 2 extra instructions in the copper list. And this is a problem. And it's a problem not for me because I know how to write programmatically a copper list and how to do this, but it's a problem for the Amiga because even if the copper has a lot of priority and can handle this situation, of course, but still you have to take into account that each operation, even if it's inside the copper list, takes time, and it's, let's say, stealing processor cycles. Because when the copper list is executing a wait, the other part of the chipset can use the CPU, the DMA slots that are free. But when the copper list is, for example, moving data, of course, there is Agnus that must decide, okay, I have to, let's say, make a priority list, and usually the processor is the last one, the one who loses the DMA slot. So you get a fatter executable with this method, and you get bad performances. So what I did, I swapped color 0 with color 1. So color 1 is the background. It's saying, when I say background, I'm stating it's the sky color. And the sand is, again, the background. So it's color number 1. And color number 0 is the black, which is the real background. It's the color I use on the edges of the screen. And this is why I told my artist, if you have to use color 0, the color 0 has to be black. So if you want to make black pyramid, you're welcome. But please do not use color 0 if you need another color other than black. And this is, if you notice, there is the red bar at the bottom of the screen in the middle of the flash party text. And this explains more or less what I told you. As you can see, the red line is going from the left. It's taking the full width of the screen. So imagine if I had the sky color on color 0, like I did for the red stripe, you will end up having the sky color at the left of the pyramid, which is unpleasant to my eyes because it's unnatural, because I didn't like it. So I added a little bit of complexity because I had to rework all the color of the palette and change the copper list colors again. And I remember it took me a whole Saturday to fix this, but I think this was the right call. And this is probably something a problem that you could encounter
I
when
did
you program
encounter it.
your video game or your
Yeah.
demo or whatever. If you must draw an object to
To be
at the edge of
fair,
the screen, and part of it is going out of the screen, like my pyramid in this case, you have to remember that there is this issue. You the the color 0 will pop up
yeah.
on the
So
left
I
or
did
on the right.
encounter
But
this issue.
again, this is not an issue. I saw some video games some demos that use color 0 and they are fine with this solution. For me, it was quite horrible. So this
So
is why I wasted.
so I was saying, I did encounter this issue. Most of the time is because you get a graphic artist and doesn't know the Amiga, how the palette is organized. Let's put it this way. And color 0, yeah, it has many uses. So if you use that color for certain things, um, then you might encounter it in other places. I have a rule that color 0 is not touched. You cannot give me an image that with color 0 being used. Um, so yeah, I did encounter it more than once. And
Yeah.
normally it's people that do not know the Amiga hardware. GFX artist that doesn't know the Amiga hardware.
The good news is that my artist is also a coder.
Uh-huh.
So
That
when
helps.
he draw this stuff, he was aware of this problem,
Yeah.
but still he didn't remember. So I had to change manually all the colors.
Yeah. It's yeah. But if he's a developer, he knows this. You don't touch color 0.
Yeah. But maybe when you have a personal paint in front of you,
Yes.
you don't take into account all
And
these problems probably, even if
sometimes you don't
you're a
realize
coder.
that you use color 0 also. It can happen when you have, let's say, two colors that are the same and you don't realize, and you think you're touching one color and you're actually touching color 0. It can happen. So yes.
Yeah, I think that let's say what we must learn is just to remember that color 0 it's a little bit different from the others.
Yeah.
For this reason.
Yeah.
But that's it. As I told you, I remember I saw some video games, I don't remember the titles, that shows the sky behind the object, which are clipped out at the edge of the screen, and the scene looks good to my eyes, quite more or less. But just to say that this is not a problem for everyone. It's for me, but for other programmers, it's not. So
No, it is for me too. I can tell you that.
it's most very noticeable on big CRTs. If you have a big CRTs, you will definitely notice this. If you are using FSUIE or WinUIE, you just have to press one button to get rid of it. But very quickly, drawing triangles. And this is the most, let's say, difficult part because it involves math, and I'm not good at math, of course. Um, the whole implementation is inside here, and if you just want to see the file, but I don't want to discuss it in length because it's very long,
Yeah.
The most interesting part is how I build the animation. And what I did, okay, at the top there are all these data structure with each data structure represents a different triangle. You see there is triangle 1, triangle 2, triangle 3. There are five triangles in total. And you can add more if you want. You just copy and paste the triangle 5 and just rename it into triangle 6, and you just change the counter at the top of the program to from 6 to from 5 to 6, and you get 6 triangles if you want to. But I just want to say that this is the let's say the core of the demo, and it's all implemented here. And the main concept is you have a stage, and every time each triangle object has a pointer to a stage. And when the triangle reach a particular condition, for example, the triangle has reached the right edge of the screen, or is at a particular position or a particular rotation angle, you just go to the next stage, and so on. And so there is this set stage macro at line 150, which does exactly this. It just changes the stage pointer offset. And this is what I call in C something like a function pointer, because this address holds the function address of the stage that has to be executed. So each triangle has this pointer, and this pointer then is read by the system, and then we jump into the actual stage. So there is the first stage, we have this scaling triangle, then it starts to roll, and then it jumps, and then there is the sand, which lifts the triangles on the top of the screen. So if any of these moments are described by a stage, and the way that you move through the stages is with this set stage macro, which is just a move.l. You are writing a new address into the triangle data structure. And this is just the bare bones of what I invented here. Please go to page number 9, and we will see very quickly how I draw the triangle.
There is before we go to page number 9, you had the stage macro. Did you want to show something in relation to this? You have this.
The stage macro
this is line 50.
Line
Okay.
150.
Yeah. Okay, no problem. Nothing. I didn't realize it's the same one. Okay, so draw triangles.
Yeah, this is where the magic happens, and this is where I heavily rely on AProcessing. So each time I have this set stage which points me to the right stage, then there is the stage implementation. So all the stage implementations have something in common, and they check where the triangle is, and then they figure out what the triangle have to do. For example, you have to jump, or to fall down, or to deform, or whatever. So a typical example is this. You load the identity because you move the position 0, 0 where the triangle is. Then you, for example, you rotate the triangle of a certain amount of degrees, and then you set where the vertices are. And you notice that the vertex 2D init I is just another macro that lets you define the three vertex of the triangle. So vertex 1 is position 0, 0. Vertex 2 is position x equal 0, and y is FFE2, which I don't remember really what number is this. Probably it's minus 15 or something like that. Because remember, the most significant bit here is what determines the sign of the number. And since it's 1, we are in negative territory. If you want to know which number is it, you have to do the 1 complement. So I'm just drawing the second vertex at 0 minus something, and the third vertex at minus something and minus something. And if you go quickly to slide number 10, there is a visual representation of this. This is a snippet that I took when the triangle is on the top of the screen, and it's not this. Okay, I think I didn't include this slide. Doesn't matter. Go to, for example, to I don't know how to explain it. So go to slide number 11. Just a very quick jump. Okay, you say that I marked the vertices with 1, 2, and 3. So let's say 1 is 0, 0, and 2 is 0 minus 30, I don't remember, and 3 is minus 15, minus 10, for example. I don't know, I made up this number. But the point is, how do I roll the triangles? Triangles are rolled just rotating along the 0, 0 point, because the way how rotate works in AProcessing is you set the origin of the point when you want to rotate around, and then you rotate. And the order is very important in this case. So what I'm telling AProcessing here is, first you set the origin of the axis to point number 1. Then you rotate counterclockwise. I don't know if it's the right word in English. It means on the
opposite side of the clock.
The reverse of the clock.
Yes, anti-clockwise.
Anti-clockwise. It's very difficult to say. I don't know. So this is why I'm doing things this way, because the vertex 1 is the one that I'm rotating around. And then when the rotation reached a particular angle, I just translate to the size of the triangle towards the direction. And this is how it works, the rolling of the triangle. I don't know if you understood something from this horrible explanation,
because we did AProcessing, I can imagine you are rotating it based on its origin.
Yeah, and the origin, each time I have to pick one vertex as the origin, and the other are computed relative to this vertex. So I call this the pivot point. So I pick one pivot point and then rotate.
Yeah,
and that's it.
The positions of the triangle while they are moving, you have a table, I assume, and you are reading one point at a time, and you say, okay, and then you rotate it, I assume, no? Or how are you doing that?
I don't get
So
the question.
the triangle comes from the bottom and starts it's rotating and then moves up and continues rotating, etc., etc., etc. How the the path that the triangle is following? How did you plot that?
The path is the following. The first scene is the triangle which is scaling,
Mm-hmm.
okay? Because at frame number 1, the triangle is scaled by 0. It means it's just a point. And then it gets a little bigger, a little bigger, and a little bigger until it reach 100%. So I'm scaling to 1. When you scale to 1, it means that you are multiplying by 1, so it's equal to the original size of the triangle. Then there is an if condition inside the stage, and this if condition states if the scaling factor is equal 1, the stage is completely executed, and then you call the set stage macro that I told before in slide number 8, I think. The set stage macro at this point changes the function pointer, and it means that the next frame there will be another stage implementation that will be executed. And the second stage implementation is telling that we want to rotate the triangle, and that the triangle must roll toward the right. So this means that we have to rotate around the right corner.
Yes, you're right.
So vertex number 1 is the right one, and then we rotate. So we compute the other 2 vertices based on this vertex that I picked initially. Then after that, the rotation is done, and of course, pardon, it's about, I think, 120 degrees. And I just translate to the right, because the same triangle, so the triangle is now at the same exact rotation like it was at the beginning, but we want to paint the very same triangle, switch it to the right. And then I restart cycling and start over until the position reached a particular position that it's hard-coded inside, which is correspondent when we are under the spaceship. Then the spaceship just creates this twister effect, this sandstorm effect. And there is another set stage macro that changes the pointer, and now it starts the movement towards the top of the screen, which is done this time rotating along the y-axis and not along the x-axis. And this is how it works in a nutshell. And this is something that makes sense to me. Probably there are better ways to do this. But what I saw that at the end, the code was quite compact, because all the implementation of this movement cost me about 5K of executable. And even if in memory terms it wasn't so big, because as I told you before, last time, the big part of the intro is taken from the bit plane allocation and the pre-tracker music. And together, these 2 components will take 2/3 of the whole capacity of the executable, and also of the memory requirement, the chip RAM requirement. So I'm pretty happy for the result, to be honest. And this is how it works, the rolling of the triangle. And if you want to see the real code, it's, for example, go to the slide number 10, and there is a link to the implementation. And I also copy and paste the sample here inside. So this is a snippet of the rolling toward the left. And if you want, you can watch it directly on GitHub.
Okay, so it's this one, no?
Yes. And this is
It's
go
line
up,
463
up.
as it says.
Yeah, this is the rotation. Go up a couple of lines. Go up again. I think the link is not correct. How is possible? I messed up something. Wait a minute. Go to, yeah. Go to line 435. Okay, this is an example of how I implement a stage. So first, I calculate where is this pivot point, so the center of the world, and this is stored inside a memory location, which is it's it's a constant actually. It's not the memory location. It start to work, it's pause. So, but this is not important. You just have to know that I put the x value of the center of the word into the 0 and the y value into the 1, and then I just call load identity and translate, which just resets the transformation matrix. Then there is a section which is not important for what I want to discuss, because it's just telling that we must start erasing the twister, the sandstorm, and this is not important. Then we have at line 455, there is a very ugly implementation of my add angle. And what I do is just add 1 to the angle variable. And if the variable reaches 360, then reset. And finally, at line 461, you just rotate. So this one, this rotate underscore reg just changes again the matrix, transformation matrix, according to the degrees that you put into the 0. So the 0 is equal to angle offset. So angle offset is what, it's just a word with a number inside that tells how many degrees you want to rotate your picture. And then there is what I told you before, we are just checking if we got n revolution and the angle. So we are just checking if a particular condition is happening. And if this is the case, we just do set stage, and we are telling, okay, you are at the end of your path, and then start doing something else. This is how I link the stages, and this is how the final path is calculated. And then if you go to line, let's see, the real stuff is at line 478. And this is what I was told telling you before, I'm just setting the vertices, 178. I'm setting the vertices, so I'm defining where I have to put the vertices of the triangle, and then I use triangle blit, which I will talk to you about later. So this draws the triangle at rotation X and at position Y, let's say in this way.
Jump to slide number 11 or 12, I forgot which one now.
12.
12.
Yeah, go to 12 and just to finish with the last thing that I
Okay.
had in mind.
So this
Which
is
one?
interesting.
Yeah, but we don't need to go to this file, this link, but
Why?
I just want to mention that
I
this
want to see.
triangle.s is the implementation of the real blitting part. So this is where the processor is telling the blitter, start drawing the triangle. And the triangle is made of two parts. So go back, for example, to slide number 11.
So
And maybe it's, yeah, go back by one.
By one? Yeah.
So if you notice carefully, each triangle is made by two different parts. There is a stroke, so the outer shape, which is just three lines, and there is the inner part of the triangle, which is where the filling algorithm is working. So what I did is the following. I reserved two extra bit planes, not full bit planes, but let's say memory areas that are not
Buffer.
pointed by the bit plane pointers, of course. Let's call this off-screen bit plane.
Okay.
And I say, please, Mr. Blitter, on off-screen bit plane, you blit only the lines. And on the second off-screen bit plane, you just do the filling. So you must think that we have these two figures in different regions of the memory, and they are, at this point, we have two shapes. We have just the stroke in of bit plane number one, and the fill in bit pop number two. And then there is a third blitter call that takes these two off-screen bit planes and combines with the scene in the real bit plane, which is the double buffered bit plane that we spoke about 1 hour ago. So the combination of, according to what you tell to this routine, the last routine, which just copies ends and orths data from the off-screen bit planes into the actual bit planes, determines how the color of the triangles, and if the triangles must be filled or must have a stroke or whatever. Because if you pay attention, there is a triangle which is not filled inside. It's like a transparent one, just the outer layers, the outer stroke is
the bottom
drawn.
one, no?
And this is done just with the logic operation with the blitter, nothing more. It's quite really easy. So this is how the drawing happens behind the scenes, and there is this extra memory that I use to just write these intermediary operations and that's how it works. What I want to add is that at first I tried to do this last part using only the CPU, the Motorola. I wrote, for me, it's quite good filler routine, which is, for me, it was very fast. But when you use the blitter, things changes a lot. If you are drawing, so these triangles are not so big. The size is 30 pixels. But still, you get far better results when you are filling and using the line mode of the blitter with this type of object. Of course, if you have very small triangles, don't bother using the blitter, you can just use the CPU. But if you have larger areas, or at least this type of triangles, it makes sense to use the blitter on stock A500. This is my opinion, and this is what the result told me when I was developing. Last thing I want to say is that I need to redo all this method also for squares and rectangles and all other shapes, because I just implemented this for the blitter. All the other shapes, for example, in my previous episode, I used squares, and the squares are currently using the CPU, and this is not good. It's good for high-spec Amiga, but not for stock Amigas. So this is something that I have in mind to do in the future. And
the triangle blit is just to show them the triangle blit routine. Okay. Of course, he's calling his routines, but in terms of the triangle blit is a short routine. Well, short routine that, okay, calls other routines, but that's the setup for it.
This is very easy to comment because it's short and it's very trivial. What it does is it reads from vertex list to the memory region, and it fetches the XY of the first vertex. Then it executes the transformation, because there is the transformation matrix was altered before, if you remember, which used rotate and load identity and translate. So let's say we have a point xy, we get point x1 and y1, which is the transformation, the point after transformation. And then we just store in the same, overwrite in the same memory area, you overwrite these coordinates. Then the blit triangle is something that you can show, but it's not so important because it's almost a copy and paste from RamGem. RamGem has a dedicated, the book has a dedicated chapter for filling algorithms and for the line mode of the blitter. So what I did is I just copy and paste, adjust a little bit something, but the code is 99% similar. And this is you will find also the bug. Inside there is the bug about the bit change that I told you some time ago. With my correction. And this is why I spotted the bug, because my triangles were flickering at some point and I didn't realize why. It took me a lot to understand why. But yeah, this is the triangle blit. If I have to do the same stuff for the square, so the square is the same, it's just a matter of at line 6 you have to say move Q3 into D2, because we have 4 vertices in a square, and then it's almost the same, I would say.
Okay.
Okay, and I think we can just finish with the last slide.
So we did 12, 13, yeah.
So in my mind, 30 minutes were enough to discuss 12 slides, and I think I was so wrong because it's almost 11 o'clock. But there are some other things that I implemented in the demo that for me could be relevant or important, like all the other things that I show to you. One thing is the movement of the spaceship, and there is a spaceship which travels at a constant speed, and there is another which uses acceleration and deceleration. And this is something that reuses the same concept that I told some on the last episode about velocity. So it's always the same trick. I have a position, then there is a velocity vector, and then there is an acceleration vector. The acceleration is the change of the velocity over time. So I add to the velocity, and then I add the velocity to the position, and that's it. That's how it works. But this also has been implemented inside the intro in my 90 kilobyte of executable. There is a spaceship regeneration, because when the triangles is near at a certain position, it gets sucked inside the spaceship. So there is a trick to alter the sprite with just a few instructions to make appear this ray. The red raster bar from RemJam, this is a minor thing, but it's very cool because for me, Amiga and raster bar are, let's say, like the mouse and the cheese. The pre-tracker music routine, this is a very cool technology from Abyss, and I had to learn how to use it. What are the benefits of this routine? Because in the RemJam book has one implementation of a mod player, but there are alternatives. P61 is one of them, but there are also others, light speed player, I know, and the pre-tracker is just another option. It works just fine.
It's
The
not pre-tracker, it's pro-tracker.
calculation.
It's pro-tracker, and the last one has also an option. I don't know if you used it. It's a cut. You can cut down the routine, so it can be compressed. It can compress itself. So you enable something in it, and the routine becomes just 5K.
Oh, this is very interesting because
Yeah,
I wasted so much space for the
I have done
tracker replay.
I will send you the code because I have done a sample of how to enable it like that.
I know that there is this Klang project that lets you do something similar. That you synthesize the samples. But anyway, I'm not an expert on this. I just use pre-made routines for sound generation.
Mm-hmm.
But I think I will read again the audio chapter from RemJam just to realize how DMA on the audio channels are
working.
Really.
Okay. From that point of view, it's fine. I think there are other things that you need to maybe look at, because that chapter has got. I mean, I don't want to make a, give a bad name to RemJam book, because I like it, but chapter 14 has got some errors in it, which I spotted, and I made them. I said them in my last streams. One of them is the way they forgot the examples. They are there, but they forgot them. Because I think the first part of chapter 14 was not written by Fabio, but by somebody else, and he forgot to mention that there are the
Yes.
examples.
I don't think it's from Fabio, this chapter. It's just an
No, it
external
is. It's
contribution.
divided in two. The chapter is divided in two, and the second part is Fabio. The first part is not, but Fabio prepared some examples, and the other guy didn't mention them. So you will be reading, and you see nothing, basically.
I hope that when you translate the book in English, you can also integrate and fix this chapter.
Oh, yeah. It's already fixed. It's already fixed.
Perfect. Okay. But so, audio on Amiga is a big topic,
Yes.
so I feel so unprepared
And
right now to discuss about it.
This is why I told you I prepared the samples, because not the sample, the routines, because I wanted to show by setting certain things in the routine, you get different things in the latest version of the ProTracker music routine. So I really like it. The P61 has got its advantages. So for compression, it's better. When you just want to play just music, I think it's better. But when you have games and you want or you want to create sound effects, I think the ProTracker, the last one, is very good. So both of them has got their things.
Good to know. Good to know when I will try to build my car.
But anyway, there's many out there, so it depends.
Yeah. For way it's full of demo tools, so probably I will find something else once. But okay, let me finish so we can go to sleep. ProTracker music routine, as I said, Sandstorm calculation, activation, deactivation. This is something that involves a little bit of trigonometry, how the Sandstorm is calculated on real time, which is not pre-calculated. It's when the blitter is erasing the scene. We have some time, and so in this fraction of time, I told the CPU, do the math to build and plot on the sprite the sandstorm. Banner tiles drawing system. This is let's say a very simple method that I used. It's very similar to IFF or just a bit plain drawing. It's just squares instead of dots. But if you feed a raw file in my system, it will just order the tiles in order like a 1-bit plain raw image, and the final outcome will be the banner. And the trigonometry tables pre-calculation. This is something that came out of my mind and also was suggested by Dario. I just don't use the cosine table. You can build dynamically and save some space. So there is all this pre-calculation at the beginning in order to figure out the cosine relative to the sine. And also, I think the tangent. I don't remember if I use also this stuff. And then we have the dynamite sprite cycling. There is say a file dedicated to the cycling of the sprite images. There is a very big copper list, which is not so interesting because it's mostly change colors and nothing more, which from 2 playfield mode to 1 playfield, but copper list is very long, but it's not very interesting from my point of view. And another topic that could be discussed is the build system and the tool change. So the tool change, so all the tool that I used, how to compile, how to generate the assets and all this stuff, how to use the genam to produce the final executable, or how to use wasm for the final executable. And probably I'm forgetting something, because this whole project took me almost 1 year, and I redid some section. I reworked some section multiple times, so it was a very long process, but I touched a lot of topics. So I don't remember what I did in January 2022, so forgive me about this, but I think that the most important part were discussed today. So I'm out of voice, so I would say
That's why you
that
wanted to
I
stop
would
there.
call a night.
Yeah, that's why you wanted to stop. So let's. So I hope, guys, you liked what Ozzy explained today. So, guys, I hope you enjoyed this topic of today. I really enjoyed it myself. I could see how Ozzy worked hard on certain things to achieve what he has achieved. But, hard work pays. He came second in the competition. So it does help when you work hard. Anyway, guys, I hope you have a good week and a good weekend. Hope to see you Friday in my next stream and in the weekend. Thank you. Bye bye.